Welcome to Earth Plus Humans, where we explore a problem in need of solutions. Hi, I'm Trislan Nelson, Professor and Director of the School of Geographical Sciences and Urban Planning at Arizona State University. My research area is geographic data science, which is sometimes called geographic information science, or GIS. But by any name, it's a great area of expertise if you want to get a job. But it rarely makes me a popular party guest. When I tell people my passion is analyzing map data, they often look just a bit panicked as they try and change the topic, and occasionally they just look like they feel sorry for me. But the heart wants what the heart wants, and I love geographic data science. For me, analyzing data and playing with pattern is fun, but more importantly, it's useful for creating solutions to pressing social, environmental, health, and economic problems. I went into geography because I wanted to work in environmental conservation, and I quickly realized that the problems I would have to address are complex. Gaining skills in geographic data science has allowed me to pose solutions to complex and critical problems. I've studied forest health, grizzly bear ecology in the Rocky Mountains, and I've helped cities plan safe bicycling routes. The applications are widespread and solutions many. U.S. News ranks geography as a top 10 science job. It isn't too surprising when you think of all the technology that is creating data that can be mapped. Much of it you use every day. Your watch, your phone, your vehicle GPS, all public transportations, and cellular and imaging satellites. We are in an era of data, and much of it can be mapped. Geographic data science is a good degree for getting a job, but more importantly, it can lead to an impactful career, creating solutions that improve society. Today on Earth Plus Humans, we are talking about geographic data science. I'm going to overcome my fear of scaring off party guests with nerdy map talk and welcome Dr. Michael Goodchild. Dr. Goodchild is a faculty at Arizona State University and a member of the National Academy of Sciences. He's widely known for his work in geographic data science. Welcome, Mike.
Thank you very much. It's great to be here.
Thanks so much for joining us. To get us started, I was wondering if you could lean on your experience in geographic data science and just tell us what it is.
Well, it's about geographic data, which means it's about data that tell you where on the Earth's surface does something happen, or where near the Earth's surface, above it or below it. And so an easy way to think about this is to think about it being the science of where. If I know where something is, what can I then do, discover, figure out based on knowing where something is? And so we might, for example, know where an outbreak of disease occurred. And from that, we could start asking why. Why did it happen there? How did it happen there? What does it tell me about that place the disease broke out there? Or think about other examples like hurricanes. Why is this hurricane happening here? Why not somewhere else? And so the where question is totally central to geographic data science. It covers the whole gamut from the humanities, through the social sciences, through the physical sciences. It deals with the environment, it deals with society. And it's become, over the past, let's say, 30 years, a very important part of people's work with data, people's work on the environment, people's work with social issues.
It seems like today people are pretty familiar with what spatial data are because they are generating it all the time just by walking around with their phones. So everyone's phone has a GPS in it and it's creating all this spatial data. Mm-hmm. But you've been involved in this field for many years, and I think of you as one of the founders of the field. How did you get involved with geographic data science back in the day?
Back in the day, and we're talking 50 years ago, I knew about maps. And I knew about computers, but I really couldn't put the two together. I couldn't figure out why you would want to put a map in a computer. And it wasn't until the early 1970s that people started demonstrating that, in fact, there were some very interesting things you could do if you put a map in a computer. So one thing you can do is to edit the map. You can correct the map. And today, of course, we're used to that happening all the time. So when Google Maps has an error, we have ways of correcting it. In the old days, the only way you could do that was to pull the paper map out and scribble on it. But today we can do that easily. And then people got into more advanced kinds of applications. They started figuring out how you could use maps to discover things, how you could use maps plus a computer to figure out why certain things happen in certain places.
So I remember the first time that having my map digitized in a digital format and asking a question using math allowed me to understand something new. And it was actually about forest succession. So we were looking at the size of trees, and I could see the pattern through time being told in the numbers.
Right.
And it was so exhilarating.
Yes.
Even though it was super nerdy, it was very thrilling.
Right.
And do you remember the first solution that you were able to generate by working with spatial data?
Oh, yeah. And they're probably back in the day that we're talking 1970s. This is probably back in the days when I was working on problems like, where should we put the next elementary school in this city? The city needs a new elementary school. Where should it go? Or the city has too many elementary schools. Which one should we close? Those are where questions. And those are the kinds of things I was doing back in the 70s. There are still outlets of Wendy's hamburgers in the West Island of Montreal that I was responsible for locating. And thankfully, they're still there and doing well. So it was that kind of location analysis. You know, everybody says that the 3 L's of real estate are location, location, location. In other words, where. And so that was one of the big openings up of this field and one of the big rewards to realize that you could do that. You could make those kinds of decisions.
What fields do you think are kind of the next fields that will be really impacted by the ability to ask spatial questions?
I think there are 2, and I've chosen these out of a large number of options, but number 1 would have to be the impact of driverless vehicles. So not just driverless vehicles, but also online shopping. And what we're going to see in the next few years is a radical reorganization of shopping. People are already doing a lot of their shopping online, and as a result, shopping centers are closing all across the United States. Driverless vehicles are going to radically change things like trucking and buses and all sorts of ways, which we haven't really yet come to grips with. And in terms of geographic data and data science, they're going to give us huge amounts of data that we've never had before. And they're going to let us help people getting around the city in ways that we've never been able to do before. So radically different. The second area is very different because it's more what people like me think about a lot, which is the social implications of geographic data science. Because one implication is privacy.
Right.
These technologies are scary in terms of privacy. We're just about to see the introduction of facial recognition in fighting crime and many other areas. If you've boarded a plane recently in some airports, you may know that your boarding pass is no longer necessary. It's now a facial scan that they do. So a lot of things like that. And one of the things we have to think about as universities, professors, is how do we deal with the social implications?
It seems like there could be a lot of unintended consequences by the speed at which technology is developing.
Absolutely. Yeah. Back in, let's say, 20 years ago, we had a very firm law in the U.S. which said that the only circumstances in which a cell phone provider could release the identity of a cell phone user was during an emergency. Right? So if someone dialed 911, they were allowed to tell the emergency services where that person was. Today, that's a completely different situation, where every day hundreds of millions of points are being gathered as a result of people using apps.
Right.
And that data is being sold to other users, retailers, who want to figure out models of how people move around the city. And the situation right now is really out of control. So that's something that we as academics can think about, understand, and try to suggest ways of improving the situation.
It's one thing for us to think about, but then the next step is going to be that the policy is going to need to change.
Absolutely.
And probably it will end up in there'll be some kind of crisis or conflict that leads to that.
Yes.
Yeah.
Yeah, I think if we look at what happened in Europe recently, where they introduced legislation, which is quite powerful legislation for protecting privacy, we can say, how did that come about? And how can we use similar techniques in the US to achieve the same kind of thing?
With privacy being such a big issue for cell phone users in particular, what can we as individuals do to protect our privacy?
So be very careful when you install an app and are given a choice between different options for allowing access to your location. So many apps will say, do you allow us to access your location at all times? And that means whether or not your phone is actually using the app or is totally idle. In other words, they know where you are at night. So avoid that option and hopefully say never allow. The reason you will be given, in the case, for example, of a weather app, is that by allowing them to access your location, they can give you better weather forecasts. But that's not really true, because weather doesn't change that rapidly in space. They can capture your location to a meter, but knowing your location to a meter doesn't help them give a better weather forecast.
Right.
So don't allow your location to be accessible unless it's absolutely important, unless you're using, for example, a wayfinding app. Don't ignore the terms and conditions, because they will tell you, unfortunately, they're usually very long and take a while to read through. But don't avoid them, because they will tell you something about the rights of the app provider to share the information you provide. If you use Google Maps, for example, and you read the terms and conditions, you will find that Google is free to share your location with any of its, quote, partners. The list of partners not specified. So this is, I think, what you can do to protect yourself is to not allow your location to be accessed unless there's a distinct advantage to you.
Right.
Another issue is accuracy, because I think we tend to overestimate the accuracy with which your location is determined. And in fact, it's not that good. So I have an example I use where my wife and I are in bed together, and we're both accessing our cell phones. And I'm accessing an app which tells me where she is. And it says she's 100 meters away. Right? In fact, she's a meter away from me. Right? So there's a lot we assume they can determine that in fact they can't. You can never determine which floor you're on of a building because the vertical accuracy isn't good enough. A lot of the time you can never determine which room you're in a building. So there are a lot of aspects of privacy that in fact can't be violated by these technologies. So don't be overwhelmed by the threat of privacy invasion, and do what you can to avoid revealing your location. We now have a developing problem with facial recognition because your camera is facing you and is always on. And so a little bit of facial recognition technology can tell the operator of your cell phone who is looking at it.
So if you're someone like me who leads a fairly pedestrian life and you feel like, well, I have nothing to hide, there's nothing I'm doing that is, that I don't want someone to see, what am I not thinking about that could be a risk to me?
Right. So what perhaps you may not be aware of is that all that's really needed is the ID of your device and where you are. And that's all these people are capturing, right? So as long as they have the ID of the device, they can link together all the points that relate to you without knowing who you are, but it's just the same device. And then from that, it's trivial to figure out where you live, where you work, where you go to see the doctor, what you see the doctor for. All of these things can be figured out easily. Who your significant other is, where you went for a date. All these things can be figured out. Now, somewhere in there, there's something that worries you.
And I'm not telling you what it is.
Right.
As much as all this privacy talk is very worrisome and makes me reflect on my own behavior, I also think a bit about my own research. So in my own research, I actually use data that's generated by Strava fitness riders to better understand bicycling in a city and to try and advocate for safe bicycling. So there's sort of this flip side where perhaps Strava users aren't intending for me to research their data, but I am, and I'm trying to use it for good. Can you comment on how universities can interact with spatial data and with the sort of growing amount of information we have to make better decisions and to do good work?
Right. So hopefully in the case of Strava, you're not authorizing them to share the data with just about anybody.
Right. And they actually won't give me anyone's individual track. Right. So it's just a number of users per street segment.
Right. So what that suggests to me is always read the terms and conditions. And prefer those apps which don't insist on being able to share your data with others. Right? I think that as universities, we have two major roles to play in this area. One is in education, because we are the educators, and because we recognize the difference between education on the one hand and training on the other. If all we were about was training people to use the technology of today, we wouldn't be asking these kinds of questions. We wouldn't be insisting that what you learn in university is something that's still going to be useful to you in 10 or 20 years. That, to me, is the difference between education and training. You can train people in today's technology, and after 5 years, they have nothing, because they have only understood technology as it exists today. But a university can provide an education in the broader principles, the things that will still be true in the future. Privacy will still be an issue 10 years from now. So will how we build our databases, how we capture information about the real world in data. So that's one major area. The second major area is that industry is usually conservative. It's concerned about the market today and how to meet the needs of that market. But very few industries are actually in the business of creating a dream technology that people will recognize as important and sign up for. They're not in the business of build it and they will come. That's where the university has a great advantage, because we can look forward. We can say, no, it's not about how we do things today. It's about how we might do things tomorrow, and how what we do tomorrow might be much better. And so we are really the thought leaders in this field. And that's what an education should really help us to understand.
Recently, U.S. News came out with an article on the top 10 science jobs, and geography was listed amongst these. And I think it is the relationship between geography and geographic data science that really makes it a powerful employment opportunity. Can you talk a little bit to future students about what kind of careers they could expect with a degree in geographic data science?
Sure. Well, the field is wide open, and I've already used examples from retailing. So one of my former PhD students, for example, has worked with Gap. And as an employee of Gap, she was the only person in the entire organization that had any understanding of spatial data science.
Really?
And as a result, she was in huge demand, because what's hard to fathom is that businesses, even though we say that location, the 3 L's, are the most important thing about business, business very often doesn't pay much attention to location. And so having someone who really was fully understanding of geographic data science was tremendously valuable for them. Other students who are working for companies doing applications of artificial intelligence to support decision-making about locations, to support where decisions, to analyze what we can learn from where people did certain things. Lots and lots and lots of applications.
We certainly see a number of internships that in cities, regional governments, local governments, which really fits nicely with the planning field.
Sure.
We're also noticing a growth of interest amongst health professionals in terms of GIS. And transportation, which you've already hit on, seems to be a big one as well.
Yeah, certainly health. And I've been struggling to figure out why it's taken so long for the health sciences to pick up on some of this stuff. There are classic examples from way back about how where helped us understand disease. And the classic example is cholera in London in the 1850s. And there are other examples too, but unfortunately, today I don't think figuring out the cause of disease is really what spatial data science is going to do. What it's going to do is to help us to administer the health system much more effectively.
Right.
To ask questions like, why does it cost twice as much to have a given operation in Los Angeles compared to San Diego? Why are so many people uninsured in certain parts of the U.S.?
Right.
Those sorts of patterns are tremendously important if we're considering the health of the population. So I think what tends to happen is that spatial data science becomes very important, a very important part of programs in public health, where we're considering the relationship between the health system and society. And that's where we can really help.
Okay, I have to ask you about your relationship to caving, because I know that you are a caver, and also that you sometimes think about caving in relation to spatial data science.
Sure. So the reason I became a geographer back in the 1960s, because I'd done an undergraduate degree in physics, the reason I became a geographer was because somebody offered me an opportunity to do a PhD in caves. And I was very interested in caving. And this was the 1960s when the world was your oyster and you could do whatever you wanted. And I thought, why not? So I signed up, and this meant spending summers in the Canadian Rockies. And after that, I suddenly thought, oh my goodness, what am I going to do next? And it turned out that at that time, geography as a discipline was just discovering computers. And so my interests fitted very well. So I kept up caving, and I think the thing that fascinates me about caving has to do with wayfinding. How do you find your way through a cave? A cave is a three-dimensional maze. Having a map doesn't help you because it's three-dimensional. So how do you do it? And that, as a question, really fascinated me and still does. So I kept up caving, and I really enjoy. One of the nice things about caving is that you feel so good after it stops, because you hurt all over. It exercises every part of the body, and so when you finish and you've had a couple of beers, you just feel tremendous.
What is your most impressive cave you've visited?
Well, the Canadian Rockies have some very impressive caves. There's one, Castle Guard in Banff National Park, which is, I believe, still the longest cave in Canada, and is right under, the end of the cave is under the Columbia ice field. So the glacier has actually pushed its way into the cave. So at the end of the cave, you hit a wall of ice. And that's a fabulous environment, just unbelievable. And it relates also to long-term climate change, because caves store evidence of the past. And in Castleguard Cave, we can look at some of the sediments and find the pollen of the sequoia. This is the biggest tree in the world that is now confined to the Sierra Nevada in California. But at times in the past, it's clearly been present much further north in much warmer periods. So a lot of interesting things come out of caves.
Like the science of where.
The science of where, absolutely.
The Columbia Icefield is an interesting reference because my husband actually was rescued from the Columbia Icefield when he fell into it when he was once visiting.
Yes.
Yeah. So I think, that changed his geographic trajectory in terms of what he wanted to study after that.
Yeah.
Dr. Goodchild, thank you so much for being here with us today. It's been really a pleasure to talk to you about an area of geography that I'm passionate about and that you helped grow.
Thank you so much. It's been a great pleasure.
Thank you for joining us for this episode of Earth Plus Humans, produced by the School of Geographical Sciences and Urban Planning at Arizona State University. You can learn more about our school by visiting sgsup.asu.edu. Music for this podcast is brought to you by Zachary Wiggins and Samuel Pena. This episode was executive produced by Megan Martin. Now get out there and be part of this solution.